And we're back. All right, welcome back to the second session on the third day of HaasTec Live here at Haas Automation. Again, we're here in the products area. I'm joined by Marcus Imes. We're going to take a look at this UMC-500SS as it's attached to this pallet pool right here in a second. First of all, I just want to say thank you for all the comments that you gave us on after the first round of videos. Lots of great comments about the VMT750. We're going to send those back to engineering and see what they can do with them. Really glad to hear about that. Please keep sending those in. We'd love to hear some examples of the actual kind of work that you think you're going to be doing on that type of machine. Really interested in that. But now we're going to look at a couple of different things here, right? We're going to first look at the pallet pool.
Yep.
Well, actually, we're not going to first look at the pallet pool. We decided against it when we were running through
Yeah,
it.
we'll kind of go back and forth between pallet pool and MRZP. There's a little bit of dead time while the probe does some probing with the MRZP. Rather than watch probe take 100 hits, we'll talk about the pallet pool.
Good time to talk about some of the specs of the machine and so forth.
Exactly.
Okay, so let's start with MRZP. What on earth is MRZP?
Yeah, so you'll recognize the acronym MRZP from our 5-axis machines and rotaries and trunnions on standard 3-axis machines as well. MRZP stands for Machine Rotary Zero Point. So that is a 2-axis intersection that tells the machine where your tilt or rotational platter is in space. And that's very important because that directly enables two of our powerful new features called DWO, or Dynamic Work Offsets, which is used for 3+2 machining, or TCPC, which is Tool Center Point Control. And that's used for
full 5-axis.
Yep, full 5-axis tool pass for the TCPC. We'll demonstrate that a little bit later. But if you remember in the past, on cold fire machines, you'd have to tell your CAM system exactly where your part was in space, and then you'd have to come to your machine and indicate it so that it was in identically the same position. If you're off a little bit, you got a nick in the table, you got another fixture on there, well, now you got to go back to your CAM system, reposition it, repost your code. Now you ran your first part, maybe you got some 5-axis offsets that aren't quite right. Well, you can't just make a simple offset, now you got to go post again. So it led to a lot of back and forth.
Potentially every time, let's say you do that job, you run 500 parts or whatever it is, you take that fixturing off, you put it away, you come back a month later to run that thing again. You can't just slap it back on the table. You got to do all that stuff again, measure it, position it, potentially repost.
Exactly.
A lot of headache, potentially.
Yeah. So we came up with MRZP. Now the machine, once you set it, it knows where in space your 0 point is, and then it knows where your work offset is, and then it can translate those at different angles and rotations, and so it's dynamically tracking, thus the name Dynamic Work Offsets. It knows where your part is in space at all times, and it doesn't care if you're in the same spot because it's figuring the difference between your program 0 point and your actual 0 point of your work offset. So you don't have to worry about it.
The second time you put that fixture on your table, you don't have to be in exactly the same place that you programmed it initially. You could be a ½ an inch off in any direction, and you're fine. The machine doesn't care, it's going to track that new position.
Yep, as long as the machine is physically able to reach the commanded positions, it doesn't care where it's at.
Right.
And we've made that process even easier now. So I want to show you some improvements we've made to the MRZP template. So we'll go to Edit, go up to VPS, and normally this is the pre-release version, but normally it would be in your probing, but now it's going to be in custom, and I'll load that up. And now we have two different MRZP settings. You have rough set and finish set. And we got some feedback that as we've made 5-axis machining very approachable, and now maybe it used to be a very high-level guy was the only guy in the shop that would touch a 5-axis machine. Now between CAM systems getting more advanced and our ease of use features like MRZP, now we're kind of getting down to the medium level or maybe high beginner. 5-axis machine becomes very approachable to them. But back to the rough set, finish set, we're getting some feedback that people weren't always sure, when do I need to do rough set, what is it, what are the settings for it. So we've taken some of that confusion out of there now. Now our templates will dynamically update. It'll read the settings from the machine and dynamically update and tell you if you need to do a rough set or a finish set, saving you time and confusion.
So it's basically telling you if you're close enough to avoid the rough set, right?
Yeah, and that's basically what the rough set does. The rough set is just getting a quick, it takes just 4 probe points real quick to get an approximate idea of where your center point is. Then we put the artifact, the calibration ball in there.
Otherwise known as a tooling ball.
Yeah, tooling ball. Put that in there, and then it takes 100 hits or so and gets a really accurate reading of where your machine 0 point is.
Right.
But so here, I just pulled up the template. We're only going to use one template, but you'll see the second time through, it looks completely different. So here, it's telling me I don't have valid settings in setting 255 through 257. One or all 3 of them could be invalid. In this case, I just killed one of them. But now it says my settings are not correct. We need to continue with the rough set. It says remove plug. You know, the majority of machines we sell are not the pallet pool. They're the standard platter UMC that has a little plug in the middle. Normally you just take that out and probe that bore.
Right.
In this case, we don't have that with our pallets. They just come from the factory.
Right, you're flat all the way across.
Yeah, there's 2 holes drilled in there for the artifact ball, but that gives us nothing to probe. So the first thing we need to do is, I just used VPS template to mill a little bore in there. So I just went to VPS, threw any old cutter in there. We have a circle pocket program, and I just milled a 1.5 inch bore.
And so since this is just for the rough set, you weren't even, you pretty much just want it to be relatively round.
Yeah.
And some diameter, right?
Yeah, I didn't even measure it. It's not that important. You just have to be approximate at this point. All the final settings come from the finish set. By default, this will be 2.0 inches for the diameter because that's the diameter of the standard platter bore. But I didn't want to do 2 inches because we have those 2 holes in the platter and it would interrupt those. So I just made my bore 1.5, I'll call that. The height also defaults to 2 inches. The standard, the standard platter is minus 2 inches in Z between the center of rotation and the platter surface. This machine is 0.515 inches above center of rotation. Kind of a random number. You might wonder how I found that out. We got all this information on our MLDs, the machine layout drawings, which are available on the UMC-500 product page. And
the MLDs are available on the PDP.
Yes.
Yeah, we've had a lot of questions about where do I find specs for my machines, particularly new machines, and all of that information is available on a separate tab on the product description page for every machine that we make on our website, on HaasCNC.com.
And same thing with the 3D models too. We're revamping our entire 3D model lineup, and they're very, very accurate to real life. One of our Texas,
you have an actual example of that, right?
Yeah, one of our Texas HFOs, I made the mistake of asking on a public Zoom call, and I guess I didn't know the answer at the time, but I was like, hey, are you got any problems? I'm looking for some feedback. And he actually said he had a UMC-1000 part, and he had about a 1/2 inch clearance to the tool probe on the side. It's a really big part, barely fit in the machine, and he used our machine model, and he said, hey, we got about 500 thousandths clearance, and they sold the machine, did the application, and it came out dead nuts on. So you'll see the new models are very high fidelity and actually come directly from engineering, and then we take out some of the extra stuff. So
right.
That's a really good resource.
So you've got access to both of those things on the product description page.
Exactly.
Cool.
Anyway, so yeah, I got my 0.515 from the machine layout drawing. And my angle, I'm just going to leave that at 0. Often you don't have to change that. If your probe comes over and falls into one of your T-slots, you can change that angle. And my distance, 1/4 inch, that sounds good to me too. So now I'm just going to call up my probe. All of our 5-axis machines come with the WIPS, the wireless intuitive probing system, which none of this would be possible without. I'll call my tool and probe into the spindle here.
So do you want Sal to come and look at this now, or?
Yeah, Sal, you can come over here.
Peek in the window here now.
And basically, I'm just going to move. I'm just going to position the probe right over the middle of the bore. don't need to be terribly accurate, but want to be approximately in the middle. And I think, let's see, 10.9 is the number I'm looking for. I know that works well. All right. Got my probe right over the top there. I'm going to go back to my VPS template, and I'm just going to hit cycle start from there, and that'll load whatever is in the VPS template to MDI and start running that. So see here, it takes a couple hits in each quadrant.
Actually, yeah, maybe we want to push back in there, Sal, and see that. Just do it slow. So this is, as you were saying, this is the quick version, the rough set.
Yeah, it only.
So here it's doing what? Just 4 points?
Yeah, I think it touches each quadrant twice.
And it's going to touch off the top, right?
And then Z once.
Right.
So now the machine knows approximately where that center of rotation is.
Right.
And that's about the end of that. So now we can get this out of the way. Now on a normal machine, I would just take my tooling ball and install it on the table. But because we have the pallet pool here, I'm actually going to do a pallet change.
Sounds good.
We'll go over to our current commands tab, and if you tab to devices and then pallet schedule table, here's where we control everything for the pallet pool.
All right, see, okay, yeah, maybe we'll jump up on here now.
You can see in the pallet pool, and Sal gets over there in a second, this is the 16 plus One Station Pallet Pool, so you have 17 pallets total. This is really good, like Corey was showing you the APL earlier. The pallet pool, the APL is limited to about 6" by 6" part size, so a little bit smaller work. The pallet pool, you go up to 8 by 8 by 16. So if you've sized out of the APL, but still want an automated loading solution.
Right. This is your next option.
The pallet pool is your next option.
Right. And you were telling me that at that point you are pretty much constrained to that size, because the pallets aren't very densely packed in there to get that many in there.
Yeah, when they cut to the pallet pool, you'll see there's basically no room between the pallets, so no, you cannot make an 8.5" part, or 8.0, that's it.
Right.
We'll have a robot option too in the future for even more flexible loading. If your part size is out of both of these, the robot will be a good option, and that's coming in the near future as well.
Right.
So you can see here we have our pallet schedule table. And I know pallet number 1 is my artifact ball. So I'm just going to push Alter to load that pallet.
So is this an example of where you were inserting a kind of a non-scheduled pallet into the stream?
Yeah, the scheduler allows me to, just like our other machines, Milton and John kind of talked about it the other day, but you associate a program to a pallet, so you can never run the wrong program with your pallet. And then you give it an order, and I want to say I want to run pallet 2 first, and then 16, and you can dynamically update that list at any time.
Right.
And it just keeps bumping down.
So in order to load that individual pallet, if it wasn't already in the sequence, you need to pull it into the sequence at the top, basically?
You can either do that if you want to wait until your current operation is done, or if you just want to throw it in and begin, I pressed Alter to load pallet and program.
Okay, right. So that just grabs that singular one if you're doing work on just that. Maybe you aren't running the pallet pool at that point. I just want to access that pallet now.
Precisely.
Okay, cool.
And one nice thing, we made this really easy. If you have existing UMC-500 programs, the only programming change to turn into a pallet pool program is you replace the M30 ending code with M299. And M299 acts like M30 if it's in single cycle mode, it just finishes and stops. Or if you have it more pallet scheduled after that, it'll continue running the next pallet.
Right. Similar to how we run the APLs, kind of the same idea.
Yeah, we kept the programming structure very similar.
Right.
So really the programming difference between an APL job and a pallet pool job is nothing other than the setup.
So here you've got the pallet scheduling business to worry about, but yeah, there you're I guess you're scheduling parts, if you will.
Yeah.
And here you're scheduling pallets, but it ends up being similar.
Yeah, so this one you have the flexibility of running 17 different programs, or more if you had multiple programs per pallet. That, with the APL, you're more or less bound to one program per APL setup.
Until you switch over. And that's a huge difference, of course. It's not just the size of the part. But
Yeah.
here, yeah, you potentially have 16 different jobs here, or maybe, you know, half and half. Maybe you're running high volumes on a couple of parts, or, you know, any mixture you can think of, really.
Yeah, that's a good way to put it, is that machine might be geared towards a little more high volume single part production. This is more low volume, high mix.
Right.
Or it could be high volume too, just with a larger work envelope.
Right, right.
All right, so now my tooling ball has made it in there. And I'm gonna go back to my VPS template.
Yeah, so for now, I think we want Sal to come back and take a look at this part of it, I think, from the front, right?
Yep.
Sal, you wanna, when the DJ over there tells him we can go.
Oh, one thing I forgot. I went back to my VPS template and it still looked the same. When the new software comes out, we have an awesome new G code called G167, and this is writable parameters. So right now, to get my settings from the probe into my MRZP settings, I have to go look at my macro numbers and then go back to my settings and manually enter those numbers. That enters a lot of possibility for fat finger mistakes or, you know, transposing a number. It's easy to do. I did it when I was setting up. And
yeah, not ideal, so we're fixing that.
Yeah, so now in the future, G167 in the next software release will allow us to read those values and automatically write them to your MRZP settings. So you don't have to guess about which setting, what's a master, what's a slave. You don't have to worry about any of that. It's going to take care of all of it for you. And it'll be more than just MRZP settings. It'll allow you to set work coordinates and some other common user settings that people have been requesting for quite a while. So I think that'll be very much appreciated by our users.
Yeah, for sure. But you're going to walk through those particular screens anyway, so give people a chance to kind of see what you're talking about as well.
Yeah, exactly. So for now, I knew my number ahead of time. I just copied it over from my macro values, and now I'll go back to my MRZP template. Exact same template, but now you'll notice the screen is totally different. It read those MRZP values, it decided it had an approximately good value, and now we can continue with the finish setting.
Right, so it knows that rough is good enough now, basically, right?
Yeah,
So
exactly.
you might come up to your machine and wonder which step you needed to do, and it may already be in that stage, knowing, oh, I know rough's good enough, I'm ready for fine.
Yep.
Or maybe like it was here where,
that's exactly the advantage, is you don't have to wonder anymore, you don't have to go find the high-level guy who knows everything. We're doing a little bit of the basic thinking for you here.
right.
So now it's asking what kind of tool ball I have, mag base or the solid ball. We're shipping everything with the solid now, so I'm just going to enter S. It'll bring up a few more options, and it's just telling me to jog the probe. Another nice feature you'll see on a lot of our MRZP templates, and like Corey was showing you with the APL setup, got a lot of GIFs in there, so if you're not sure about exactly what we're asking for, just spend 10 seconds and watch the GIF. Movie's worth 1,000 words.
That's right.
And now it's asking for the diameter of it. By default, this defaults to 1 inch, but this is actually 25 millimeters, which you machinists will know is 0.984. So don't assume your ball is 1 inch or 25 millimeter. Take a mic the first time, check it. For finish setting, it does matter.
Right, at this point, you do need to worry about that a little bit. You've got that ground ball in there, you may as well know exactly what diameter it is.
Yeah, at this point, for the finish setting, we want to be very accurate, because this will determine our overall volumetric accuracy of 5-axis moves anytime we're not at B0, C0.
Right.
All right, so now I'll just come over and hand jog that down. And again, I'm just putting it over about the middle top of the ball, about like that. Go back to my VPS template, and I'll hit cycle start, and that'll start the probe here. And the first question, it actually comes up and asks, would I like to probe at B90? So obviously, to get the tilt center line, we can't probe just at B0. We need to be some degree off of that.
You have to have an angular motion in there.
If I answer no, it'll go to 0, -35, +35. And that's good, that gets pretty close. But a lot of times we're going to be working at B90, and for the most accurate representation of that point in space, we want to probe at 90 degrees in any case that you can.
There are reasons why you might not be able to do it at 90 degrees though. That's why you have that option though, right?
Yes, this is why we ask you. The Haas tooling ball that comes standard is long enough that it clears from the spindle center line to the side of the spindle head. If for any reason you lost this, you can buy another ball, maybe it's a little shorter. Make sure you got enough clearance there so the side of your spindle doesn't crash the trunnion when it's at 90 degrees. But if you're using all the included equipment, you can say yes, and we would recommend you say yes anytime you can. So I hit yes again, it's going to ask me to hit cycle start one more time just to make sure. And now it'll start probing the heck out of this. And this cycle runs for about 7 minutes, so we'll let you watch a little bit of it, but we're going to start talking about some other aspects of the machine as well.
We'll watch it for like 10 seconds.
Yeah. You guys have probably seen probes hit 1,000 times, and if you haven't, here's a couple more for you. All right, so while that's going on, let's get a little bit better look at the pallet pool here.
Let's move over here. I'll move over out of your way a little bit.
This is very similar to our other palletized machines. We have the ready button here, so when you're in automatic mode and a pallet finishes, the pallet pool will automatically drop it off here at the load station for you to reload and do whatever you need to with. We have a couple handy features I'll show you. We put the slot in the side here so you can spray off some chips and coolant without hosing yourself down. I think we've all done that a time or two. The pallet indexes, just like our other ones, so if you had a multi-sided, you could probably fit a real small tombstone on here potentially if you're making maybe like little medical parts or electronic parts. You could stack them, up to 16 inches high and actually run a lot of parts on one pallet. That's handy. We have the home switch here and a position switch in the receiver, and so it has to be at home before it'll unload the pallet. So if it won't do it for you, double check that you're at home.
Right, so just like the ECs and the VC400, you only got the one spot where you can really, where it knows that it's ready to go and you're safe to load the pallet.
Yeah, exactly. And same thing with the operator door too. We got a proc switch up here, so it'll tell you the door's open. I can't go in there.
Right, so the pallet change is not going to come around and try to ram into the door. That'd be bad.
Crash proof it a little bit. And you can see the pallets here. It comes right off, but maybe if you're cranking on a taller fixture or something, obviously you don't want it falling on you. This lever here, now the pallet's locked to the base, and so really anytime you're reloading is probably best practice to lock that lever in place so your pallet can't tip over, fall off, hurt you. And if you forget to unlock it, you can actually leave it locked. We designed it so that when the forks come in, it just pushes that lever open, unlocks itself, so you never have to worry about it trying to pick up a locked pallet.
Right.
So one more way, crash proof things a little bit for you.
So we kind of talked about the work envelope that you've got here. So it's 8 by 8 by
16 tall.
Okay.
And the 16, if you were to go all the way up to 16, you don't have a lot of room left for your tool because you have about a little less than 20 inches of total Z clearance. So if you are going to do a real tall part, again, look at the machine layout drawing, do a work holding plus tool stack up, and decide if you can make the parts in that work envelope. Cool.
Well, we talked about what you do to prep your program. All you need is an M299 to turn into a program that's accessible for use on the pallet pool, right?
Yep.
I think that's kind of about it, right?
Yeah. So this is
anything else you want to say?
Yeah, I think we're getting close to the end of the probing cycle here, and just to show you why all this matters, I took a little program. I just hand wrote a program using tool center point control, and we'll show you the difference between maybe like in the past how you would chamfer something and now how you could do a 5-axis chamfer, and we'll do some pretty fancy 5-axis moves, and I programmed this all by hand. What would have taken thousands of lines of code in the past now is just one line of code and a bunch of fancy math in the background that some geniuses up in software figured out. So thanks guys, I don't have to do that math.
Yeah, right.
I appreciate that.
And so that's something you have to have your MRZP correctly set for though, right?
Yeah, exactly.
Otherwise you're going to have some interesting incidents happening.
Yeah, I don't even actually know if it would work. I've never tried it.
Yeah, maybe
but,
it wouldn't. Yeah.
It probably wouldn't. I'll assume not.
Cool. So are we coming to the end here on the probing, or?
Yeah, we're getting close. So, yeah, just to emphasize again, a lot of people were asking about the vertical mill turn, and Haas is really expanding our. It was funny. I was at IMTS last year, and everyone told me, Haas is never going to make a mill turn. Well, I've learned never to say never here at Haas, because when we see a good opportunity in the market, or same thing with like a lot of our automation, you'll notice a lot of new pallet pools are coming out for a lot of new machines.
Yeah, we've really been making huge steps in those directions, in multiple directions. Robots, automatic pallet loaders, pallet pools.
I heard rumblings of an EC-1600 pallet pool.
Wow.
That's still out there a little bit, but...
that's a whole different scale of parts right there.
Yeah, so for the big stuff, those big customers are not being ignored. We're just kind of working our way down the machine line. And I think everyone's trying to make more stuff with less people and keep that spindle turning more, because that's how you're making money. And
that's right. I mean, this is another example of this machine is one that you can set and forget to some extent. I mean, you've got 16 pallets. You're running unattended for a long time.
Yeah, you load this up at the end of the night. You got to figure most 5-axis parts. It's not hard to get an hour or a half-hour cycle time on that.
Right. So this thing might be still running the next morning when you come back in.
And that's exactly what we're thinking with it. Is this is free money at the end of the day. You load up a pallet pool or an APL, and you combine that with our WIPS wireless probing system. If you're doing a lot of unattended work, it may not be a bad idea to probe the part every time, just in case you get a misload, or we haven't observed any problems, but when you're doing unattended, it's always nice to do some broken tool detection, which the VPS templates also allow you to program really easily.
Yeah, we've talked about that. I think we've talked about that a little bit this week. I think actually on Friday, Mark's going to even talk about that a little bit, about how do you kind of proof your program so that you're going to run well unattended, because a lot of things can go wrong that an operator might be able to take care of if they're standing there by the machine. But if you've got no operator there, you need to make sure things are a little more locked down. And like you said, things like a probing check in between cycles.
Absolutely.
Did I load my part correctly? Did I do all my features correctly?
I come from many years of Swiss background, and when you came in the morning, if things were bad, it was a pile of bad.
Right,
There's never just one thing bad. It was almost everything. So the number of checks you can put in there to prevent cascading crashes from happening takes a little extra time in cycle, but when you consider you're getting 8, 10, 12 hours of free labor.
Yeah, you're doing that work without anyone standing there anyway, so it's probably worth those safety steps.
Yeah. All right, so now we're done here. If you saw the observant people would have seen the red light flash for a second. That's because it read the G167, but that's not in software yet. That's our parameter write code. So that was the new template trying to dump all those numbers we just figured out into the appropriate parameters. But now you can see we do have good numbers in there, and I'll do one more pallet swap, and I want to show you what this all is used for with a little tool center point control dance. So I'm going to take pallet 4. Let's see here. And I'm going to load that up with insert. Oh, operator station is not locked. It is locked. Never got that message before. It says operator station is not locked. Doing some thinking for you apparently. All right, minor technical difficulties. I've never gotten that message before. Operator station is not locked.
I don't know.
Oh, I know what it is.
Yeah, this one's out of position.
It's the home switch.
There we go.
Remember that home switch?
I was sweating there for a minute. Hey, it worked like it was supposed to work, actually.
How? I can't crash the machine.
It didn't want you to load that way.
Yes. All right, there we go.
Cool.
Do a little bit of thinking for us. Thank you, machine.
It's always that way, right? You're like, why isn't this thing working? Well, it's actually telling me that I should not do something that's unsafe.
And actually, that's something that I used to do a lot of in the field training. And often when you're having problems, people, you kind of look at the last thing that happened, but oftentimes your problem started several steps ago. So that was one thing, particularly in Swiss, when everything's got to be perfect, when I was trying to hold, 3/10 all day. You really got to go back through all the steps from the beginning. And lots of times you'll find little things, maybe you didn't set a work offset
quite right or something, or
early on, and that will have a cascading effect. So it's always good to double check from the beginning, because oftentimes it is something very simple like that.
Right. Well, it's a lot like the comment we got at some point, I think, in the last day or two, where the guy was like, I can't hear the audio. And then a couple minutes later, he said, well, I forgot to plug my headphones in. So, yeah, you got to do the basics first. Okay, so you're loading.
All right, now I'm going to take the other pallet out of the machine.
Right.
Swing that
around.
So
we put away the pallet that was in there.
Yeah, it always has to put away the load station pallet, and then it'll get the one from the machine, and then we'll grab the other one.
Right, so you put away the one that was in the load station, you're going to put that pallet into the load station,
yep,
and then get the one we want to load.
Exactly.
Right. Cool.
See that slide in there on Sal's camera? I know this all clears. I suppose I probably should have sent the probe home, but I know that we're safe either way. Don't want to mess up your nice fancy probe.
So in this case, we both are we supplying that particular artifact, as you call it, or tooling ball?
Yeah, that
in this configuration. If you're getting the pallet pool.
Yeah, the tooling ball comes with your whip system, and we pre-drill the holes in the pallet for it.
Okay.
So
that's what you were saying.
Yeah.
That's the ones you didn't want. You didn't want a machine when you were putting your extra bore in there.
Yep, that comes from the factory. And now. We will load pallet number 4.
All right, so now we're going to get our rotary table.
Yep. And now this will be this will show you why all this matters. I'm sure a lot of you are familiar with MRZP and tool center point, but to those who aren't, we'll show you how much easier this makes it, because what I'm doing in this program with a few lines of code literally would have taken thousands of lines of code and a very expensive CAM program in the past.
Right.
And now it's become so simple you can do it by hand, and it took me about 5 minutes.
That's crazy.
I will mention to go from a standard tool height offset to tool center point, machinists will recognize the G43 code as tool height. G234 is tool center point control. So whereas G43 tool height is only looking at the length of your tool sticking out of the spindle, G234 is looking at where your tool tip is relative to the work coordinate systems at all times. So in 5-axis, if I did like a sweeping move with only G43 tool height, it would actually cut a scallop through my part. But with tool center point control, the machine's going to actively track where that is and maintain that point in space relative to the workpiece at all times.
Right.
So I'll call up my program here. And Sal, if you want to come in here. So this would be just kind of a standard 2-axis deburr path. This kind of traces around the outside. We could orient that to a couple different positions. But now here's a similar thing with tool center point control. I really like that last move because it kind of helixes in, but that's actually drawing a straight line as it goes around. And all my rotary moves there, I'm counting it right now, I got 6 lines of code to do this.
It's pretty cool.
So as you can see, that makes it a lot simpler and just a lot more user-friendly. And the code is a lot easier to decode too. If you got a bunch of random C and B values and you're having a problem like gouging is a real common 5-axis problem. And trying to figure out, exactly which line of code is doing it when you have 100,000 lines can get pretty tricky. I've been in some shops and we've struggled with it in the past. And the tool
now
center
these
point
machines
control
are just coming with it. It's just kind of it is an option, but it's just, yeah, it makes it so much easier.
Yeah, it makes it easier because now you're looking at relatively standard G code, and it's just a lot easier to debug when you do have a problem.
Yeah, you think there's no reason you would invest in this machine and not take advantage of that technology.
Absolutely.
Yeah, just so straightforward. Well, I think that's kind of it, right?
Yeah, exactly.
Thanks so much for walking us through this machine, pallet pool, and in-depth introduction or refresher on MRZP.